Hello and very good afternoon, all of you. Once again, and welcome you all to the post-lunch session of Day 3 on STTP on GIS for architecture and civil engineering. Um, okay, so today we'll be exploring more tools related to इसमें analysis part is filter queries, spatial selection, and similar other tools. And our eminent speaker today is Miss Urmi Sharma. So welcome, ma'am. Okay, so let me start with the introduction of our guest today. Today's guest is Miss Urmi Sharma, Assistant Professor, Department of Geography, Mohanlal Sukhodia, University Udaipur, Rajasthan. She is pursuing PhD on use of satellite and geospatial data to study urban landscape dynamics and surface head fix head fluxes over eastern Rajasthan, and part-time research scholar at Indian Institute of Remote Sensing (IIRS) ISRO Dehradun. She has done MA in Geography and BA Honors in Geography, and her achievements include gold medalist in university in post-graduation 2014 and first position at university and graduation 2012. Her fields of specializations are urban geography, thermal remote sensing and GIS, geomorphology, and software skills. Interestingly, she is skilled in remote sensing and GIS softwares, QGIS, NV, ArcGIS, RDAS, Imagine, Saga, ID, RISI, and so many others. And major research projects she has been involved in: electoral information system for governance and development, electoral information system for governance and development planning, e-governance initiative under RUSA MHRD Government of India, and which is ongoing project. And her experience include she worked as research assistant in Geotech 2016, 21-day training on geospatial technologies sponsored by DST and RDMS and organized by Department of Geography, MLSU Jaipur in 2016. She is coordinator of 21 days national level NRDM DST Winter School in Geospatial Technologies, conducted from November 2019, and she is working as a coordinator of Indian Institute of Remote Sensing ISRO outreach program at Department of Geography MLSU since 2018. She has also conducted an online demonstration of TNT MIPS image processing and GIS analysis softwares as coordinator at Department of Geography MLSU in collaboration with OPSIS system Kolkata in 2021. And then she is also convener of 4-day university level workshop on mapping and analysis using QGIS, and organized in the month of May 2021. She has also published many papers. Some of our analyzing relationship between land use, land cover, and land surface temperature over Bhilwara district using geospatial techniques, and ecological analysis of literacy in Rajasthan, and many more. So, welcome, ma'am, to this STT program, and we are very much delighted to have you on this training program. Over to you, ma'am.
Thank you so much, ma'am, for inviting me to this lecture, and I am very happy to be a part of this workshop. So, without taking much time, I just want to start my lecture. I'll just share my screen. Is it visible?
Yes, ma'am.
Okay. So today I'll be talking on GIS data exploration, and so far I hope you have done a basic data structure, and I hope participants know that two types of data forms are there in GIS. One is vector and one is raster. So basically, GIS database has a number of layers. That is the actually the strength of GIS, that we can handle a number of layers simultaneously in the software. And these layers, suppose if you are I'm just interrupting just for a second, ma'am. Is it okay to use English, or will it be okay to be in Hindi and English both?
Actually, some of us are from Tamil Nadu, ma'am, so we don't know
Okay.
Hindi. Ah,
All
just
right,
a
all right. So
continue.
I'll try it in English. Okay. So I was saying that GIS provides an environment where you can use a number of layers simultaneously, and in on all these layers, there are hundreds of attributes that are associated with those layers. So how to begin our information? How to begin to analyze the data that we have. So many data, so many attributes that are associated with it. So the question here is how to start our understanding, how to explore the relations that are there in the layers, that are there in the attributes. And from there, if we can able to formulate some kind of research questions or some kind of hypothesis for our work, this all process is known as GIS data exploration. So today's lecture structure will follow, first of all, editing of the attribute data. What attribute data is, we'll talk about it in next slide, and working with the fields. Secondly, we will talk about some filtering operations in quantum GIS. And finally, we will do some demonstration work on query operations, both attribute data query and spatial selection things. So data exploration has two parts. Number one is attribute data query, and second is spatial data query. As by now, I hope everyone is aware that attribute data is also known as a non-spatial data, a data which does not have the spatial or the spatial information with it. But the spatial data has a locational information associated with it. Suppose if I say you have digitized a road layer. Now road is a vector layer, okay? And it is on your map. It is, you can display it on in a software. But if you have to know what is the name of the road, what is the length of the road, these associated features or these associated characteristics of the spatial data is saved to in the form of attribute data. So attribute data has the characteristics of the spatial features. Suppose we say vector data has three forms: point, line, and polygon. So the additional information of this vector data stored in a form of table is known as attribute data. So the attribute data can be in the form of a text. Suppose if it is a name, it will be in the form of text. If it is a number, suppose length, suppose date, suppose introduction year, so it will be a number. All these are the forms of attribute data. And if we run a query, a kind of expression on the attribute data, it is known as attribute query. And we use certain forms of equations in the form of expressions. So the first part of the lecture is attribute data exploration in quantum GIS. Attribute data is stored in two forms. Number one is in the form of a table, that is known as attribute table. And secondly, in the form of non-spatial table. So the first attribute table is associated with the spatial data only. So when you open a data in your software, suppose you open a boundary file or a map. Suppose I say I open a Rajasthan boundary district map in Quantum GIS. So the attributes associated with those maps will be will be available directly in the software. But if you don't have a spatial data, if you don't have a map, if you don't have a boundary map of any state or any plan you have, suppose you just have an Excel file. Suppose the census data of a population is available in the form of Excel data. So it doesn't have any associated spatial features. That is categorized as non-spatial table, and you can find it in the form of Excel files or database files or Access files. So GIS also provides an opportunity where you can join this non-spatial data table to your spatial data. That is a part of table joining. Here I'm restricted to some of the features of exploring the attribute data. First of all, what are the options that we can do with an attribute data? Suppose you have the attribute data and you want to add something to it, or you want to delete something. I'll just show you an attribute structure, how it looks like. So all these features like ordering, you have to manage your data in ascending order or descending order, or you have to arrange it in an alphabetical order. That you can do in GIS environment. If you have to add a new field to your existing data, that also can be done in the GIS software. You have to remove the unwanted fields, you can do it here only. You can calculate certain new fields also. So first of all, we'll start with ordering of the data. And for that, I have this data of Udaipur. So I just open my software here and I add my first layer. It is a vector layer, so I go to layer, add and add vector layer. So I'll open this Udaipur shapefile. Now you see, it is a Udaipur district map, tehsil wise district map of Udaipur, and this is a spatial data. Now on the top menu bar, below the menu bar, you'll see that there is a table format, this table icon. If you roll your cursor over it, you will see it is written here that open attribute table. So when you click this option, a row column form of table is there on your screen. Now this is the attribute information associated with that map that I have shown you. This is a 11 tehsils are there, you can count it here. Tehsil names are there and various associated population features are listed here. Suppose first is the total sex ratio, the rural sex ratio, urban gender ratio, then child sex ratio, literacy population, male female literacy percentage populations. All these are the attributes that are associated with that spatial data. So my first task is to order my data. Suppose the tehsil names, you want to arrange them in alphabetical order. So on the top column, that is the column field, this is known as the field, and these are known as the records. In the tehsil name, I click here and you see a small triangle appears. This is the ascending order, or you can say alphabetically ascending order. If I click it again, it will arrange the tehsil names in descending alphabetical order. So one thing that you can do with the attribute data is ordering your data so that you can easily find out any of the record that you want to search for. Similarly, if you have a numerical data, suppose literacy data is there, and I have to see what number of tehsils or which tehsil has the lowest literacy rate. So I just click here and it will arrange my data in the ascending order. So you can see here the Kotada Tehsil of Udaipur has the least literacy rate. It is 26.5. So these are some of the features that you can do it with the attribute data. I have made a table here, and so you can do this task on your own in tomorrow's hands-on session. So suppose we have to identify the tehsil with highest sex ratio. So you open the attribute table, you select the sex ratio field, and you click the field tab. This way you can arrange the your data in descending order. So the first answer to the first question is, it is the Jhador tehsil with 977 value of sex ratio. Similarly, lowest sex ratio belongs to the Girwa tehsil with 941 value. Similarly, you can search for highest literacy rate tehsils and its value, and the lowest literacy rate tehsil and the value. All right. So this was the ordering of the attribute data. Next comes the adding a field to the existing data. For this, I'll open another data here and we'll open the data1 file. So on the screen, you can see it is a Rajasthan district-wise map. And if I open the attribute table here, you will see there are almost 5 fields that are associated with this map. Now suppose I want to know that how many districts are there in a divisional map. So I just show you this divisional map of Rajasthan, and there are 7 divisions that are there in the Rajasthan. Administrative divisions like Ajmer, Bharatpur division, Bikaner division, Jaipur division, Jodhpur, Kota and Udaipur division. And these divisions have some number of districts associated with it. Suppose I have to add this information, this data, to my existing data. So I need a division field in this attribute table, which is already not there. So first of all, I'll create a space for division and then I'll add my value manually. For that, you have to first enable your editing mode. So on the screen, you can see a pencil type of icon here, and when you lower your cursor there, you'll see it is a toggle editing mode. You will have to switch it on. When you enable this button, you'll see many of the options are now enabled. From this menu bar, there is an option of new field. You can see an icon here. You just click it and add field window will open. Now the software is asking what name you have to give it to it. Suppose I have to add division name to all these districts. So my field name will be division. If you want to add some comment to it, like if you want to add that these are the Rajasthan administrative divisions, you can add it in your comment. Next comes the type. What type of structure this field will have, whether it is a text data or is it a number data. So you can select it from here. By default, it says it is a whole number, but since division are in alphabetical numbers or strings format, suppose it is a Bikaner division. So Bikaner, this is known as string data. So you have to select text string. Then comes the length. Length means how many alphabets will be there, maximum alphabets will be there in your data. Suppose one name is Bharatpur division. So you have to count all the alphabets BHARATPUR. There are 9 alphabets. So you have to select the maximum length that your data will have. I'll give it a length of 20 and you click it OK. Now you see a new field has been added named division. But you see the values are null because I have not added any value to this. So from the map, the task for the participants is you have to add a division field to your district layer, and in that you have to type all the divisions using this map. So if we start with Ajmer division, so you can see Ajmer division has 4 districts: Ajmer, Tonk, Bhilwara and Nagaur. So I'll just type here Ajmer. Similarly, you can also arrange your districts here. Next one is Bhilwara. Then it is Nagaur. And it is Tonk. In this way, you have to add all the divisions to these districts. This is known as adding the field and adding additional data that you want to associate with your shapefile. Now, what if we have to delete a field? We have some data, some information here, some field data is there. Suppose the state column you see says these districts belong to Rajasthan, and we know that there is no another state associated with this file. So this column is not useful for me. I want to delete it. So in the editing mode, just like you have added a new field, इसके पास में एक button है. This is a delete field option. You have to click it and you have to select the field that you want to delete. Suppose I want to delete the state field. You select the state field and you click OK. Your data has been deleted. If you have to save it permanently, you first save your edits from the Save Edits button. Then you switch off your editing mode. So I have already prepared one such data that that I have added the divisions to it, and I have removed the state column from it. It is data 25. This is a district map. So you can see here all the divisions are there. You can arrange them in alphabetical orders or orders that you want. And the two other columns that are associated with it is the total population numbers and the sex ratio of each district. All right. So this is my final data, or this should be the output of your first exercise. Adding a data, deleting some fields accordingly. Now there is another option. See, you can add a number of fields that you want. But suppose, as I'm aware that you are from engineering background, at times you collect some locational data. You do some GPS survey and then you have a point shapefile kind of output. So this is a point shapefile of schools in Rajasthan that we have created. And in the attribute table, you see there are just two fields. Number one is ID and another one is the name of the school. All right. Suppose I have to add the locational, that is latitude and longitude information to this point layer. Why I have added this option here in the lecture? Because I believe that in GPS surveys done by you, if you are creating some plan, you go to the field and you collect some GPS points. These points will be in the form of point file. And if you have to see the latitude and longitude information of that, you can add this field also to your data through GIS software. So the procedure is, in the software, in the main tab or on the main menu bar, you see an option of processing. In the processing, you go to toolbox. A list of tools will appear here. Since you are working with a vector layer, so you have to search for an option of vector table. You click this option, vector table, and there is a fourth option that says add XY fields to layer. So you double click this option. A new window will open of adding XY fields to the layer. Suppose you don't know about the operations or the functions that you are using. So you can see a brief description of the option here. It says that adding X and Y, that is X is latitude and Y is the longitude field to your point layer. So my point layer is School of Rajasthan. It is already there in the input data. The coordinates are associated here. So you have to select a geographic coordinate system, that is WGS 84 with EPSG code of 4326. It is already there. And here you can click run. If you have to save this file permanently, you can go to this field and you can save your file through this option, save to file. But for now, I'm just doing this on a temporary basis. I just run this option. This is finished. You can see it in the log menu or the log message that it is completed. You close this window and you see here another layer of edit fields is shown in the layers panel. And this symbol says that it is a temporary layer. You have not yet saved this layer. You can just check your data first. So I'll just open the attribute table of this added fields. And here you can see the XY coordinates, the latitude, or you can say X is the longitude and Y is the latitude information associated with your point file. So you can easily generate the latitude and longitude in GIS. So this was about adding a latitude longitude field to your existing attribute data. Next we'll see Renaming a field. Suppose you have collected the data from a secondary source, or someone has given you the data, but you have to arrange your data, or you feel that there are certain field names that are not very clear to you, or you want to change it for your own research purpose. Suppose I open this attribute data again. This was our division map. Here you can see there are two field names, join TP and join SR. So since this data has been given to me by someone else, so he might have added this name, join TP or join SR accordingly. But if I have to change this field name, join TP, to total population, what do I have to do? So the task is you have to rename this join TP field to total underscore POP. That says that it is a total population data. What you have to do, you have to again go to the processing tab, you select the toolbox option, and in the vector table only, you will see a rename field option. Okay, so you select this, open this option, rename field, and it will ask from which layer you want to change the field name. So I say it is data 2. What is the field that needs to be renamed? You click here and you can see the field names are there. I'll select join TP. What the new field name that you want to give? It will be total underscore POP. And you just run this option. So a new renamed layer has been created. Yeah, let's see the attribute table. Here you can see the name of the field has been changed. Initially, when I told you the division layer, it was entering the records. Here you can, by this function, you can easily rename your field. So these are some of the options that can be explored related to the attribute data. Adding a field, deleting a field, or you want to rename a field. But there are many options that can be done using attribute data. These are some functions provided in the GIS options. Some of the functions that can be of use to you guys will be like operator functions. Suppose you have to add two data sets. You have to subtract a data set. You have to divide some values. You have to make some multiplication, some mathematical operations are there. Or you have to do some kind of logical reasoning to your data set with and or not, like these kind of options. Similarly, there are some geometrical
Excuse me,
functions.
ma'am.
Yeah.
Asati sir, please turn off your video. KK Asati sir, please turn off your video. Okay, madam, you continue.
Okay, thank you, sir. So another option sets will be of geometry functions. Suppose you have to calculate length of some object. Suppose you have a road layer and you have to calculate the length of the road. You have to calculate area of a parcel. Suppose you are working on a plan. So you may need to calculate some area of that. You may need to calculate the perimeter of a bounding box or some sort of functions. These are known as geometry functions. And advanced level of mathematical functions. Suppose you have to calculate the square root or some trigonometrical angles you have to calculate, or you have to calculate natural logarithm of certain values. We have to calculate maximum, minimum from the data sets. All these functions are available as in the form of a function list in the Quantum GIS. So these kind of operations you can perform in the field calculator option that has been provided in the software. So let's take this query and we'll see how we can calculate area of a polygon in square kilometers. So my data here is again the data of Rajasthan district, and I open this attribute table here. Now see, all these districts are in the form of polygons. Suppose I select here and you can see Ajmer district has been selected and it is a polygon feature. Now I have to calculate the area of this polygon automatically. I want that my attribute table automatically creates an area and calculates the area of this geometry. So what will I do? First, I'll add a field, and that field will be area. You can also say it is in square kilometer. It will be it can be into decimal numbers also. So I'll say decimal number. You can define the length here. I'll keep it 10 only. And you click here, okay. Okay. This way you can add a field and you can do the calculation operation here. But another option is that you don't need to create another field to it. You can simply go to the field calculator option that is shown in here. Open field calculator. It will open a window in front of you. So you can see here, the first, this one is, it says create a new field. What field name you want to give it to it is area. Area square kilometer. It can be a decimal number also. Output length, you can also define it from here only. And this is an expression window. That means the calculation part will be shown here. And here you can see these are the functions that are available in the GIS. Aggregates, arrays, color, conditions, conversions, date and time. Fields and values are important. Fields and values are the fields that you are working with your data. So now our task is to create area or to calculate the area of each district in square kilometers. So we have already added a field named area. We have given it a decimal number, length we have given it to 10. And now you have to select geometry option from the function list. So here you see geometry option is there. You click it and it will show you a number of geometrical functions that are being given in GIS. There is $length, geometry. We have to calculate the area. So you go to $area option, okay, and double click it so that it can easily go to the expression window. $area, and here you can see the preview, okay. It says, for example, Ajmer it is, so it has calculated this area. But this area has been calculated in square meter because of the projection that is associated with your spatial data. Now I need to create it into square kilometer. So I will divide my area. So you can use the division function here, division operator, and you type simply 10 to the power 6 zeros, so that my area will be in the form of square kilometer units. Okay, these are the simple conversions that you can easily do. You are from the engineering background. So I'll hit here OK. What's the problem? Just a minute. Okay. Actually, what happened is, in the field calculator option, you can see on the first option here, only update one selected features. So I had selected the Ajmer district, that's why it has calculated area for that only. You have to check it off so that it will calculate this area for all the districts. All right. So you can see here that area is there. The area has been calculated for each polygon, or you can say for each district. Another calculation that we'll do with this data is we will calculate the population density of all the districts. Now you know that population density has a formula of total population divided by the total area. From this, we'll perform another field calculation. You just open your attribute data here. You go to field calculator, and our new field will be P den, that is population density. Now it will be a whole number, and I just restrict the length to 3 digits here. Okay, 3 digits are here, and I'll use the expression here. So I'll select the field of first total population divided by the area. Okay, in the preview option, if your expression, if you are using this expression, and suppose you don't get an, you are not writing it in the correct format, so the preview will say the expression is invalid. You have to check for the expression. Suppose these uh, commas or all these expressions need to be in the exact form. If it is right, if it is true, then it will result into the true output. So I'll hit here OK. You see, population density of all the districts have been calculated, and you can arrange them in ascending or descending orders. So to extract additional informations that you want to extract. So this was about the field calculator options that you have. From engineering point of view, I don't know much of your, you can, I think area option, calculation of area in square kilometers or conversion of units will be beneficial for you. So this is one example. The second segment of the lecture is using filters in Quantum Gis. What filters are? Suppose you have a number of records in your data table, and you have to identify, you have to just look for one single record and their associated values. So you don't have to explore all the table by scrolling from the sheet. What you will do, you will use some smart filter options in your GIS. For this, we will use two data sets. That is, I'll just open my files here first of all, and then I'll let you know. So again, it is a vector layer of Indore. I have a Indore ATM locations in a form of point file. So this is these are the point ATM files of ATM data sets of Indore. Let's check the attribute table. Here we have ID field, we have the bank name, and the third field says deposit FA. Deposit FA means it resembles the deposit facility, whether it is there or not there on the bank. So you can see in the deposit facility, you will find only 2 digits, either it is 0 or it is 1. So it is kind of a binary coding that has been set to this data. 0 means these banks having 0 deposit facility means they don't have the deposit facility. And if it is 1, that means they have the deposit facility. Now you can count on all the records. How many records are there? You arrange your data in ascending order, descending order. You see there are total 37 banks, 7 banks in Indore that are in this file, and all names are there. State Bank is there, Bank of India is there, Canara is, HDFC, all these banks are there. Now we'll start with filter. Suppose our question is how many number of banks are having deposit facility. Okay, I have to filter my data from this whole set. In the attribute table, you see there is a filter or funnel shaped option which says show all features. So currently at present, it is showing all the spatial data in this attribute table. You click this option and you will see a number of various filters that are there, that are available here. You go to the field filter option. In the field filter option, it will show you the fields that are there in your data sets. So we have 3 fields: ID, bank name, and deposit facility. So I'll select the deposit facility. In the deposit facility, what I have to search for, see the question again, how many number of banks are having deposit facility? That means banks with deposit facility of value 1, right? So in the attribute table, you type here, this is a cell, you have to type 1 here, and you just hit enter. See, 18 banks have been listed from the whole list of 37 banks, and it is showing only those banks that are having deposit facility. You can check it from here also. It says 1. All right. So these are the simple filter options. Let's go to another filter question. How many HDFC banks branches are there in the data? Suppose you have to search for a particular bank name. Okay, how many you have to calculate for HDFC banks? So you don't need to calculate manually through the data. I'll just remove the filter by clicking on show all features options. You select here again, go to field filter. You select the bank name, and my bank name this time will be HDFC. The moment you start typing the name, it will showcase, what do you mean by this HDFC bank option? So you can also click here, okay, and hit enter. Here you will find all the HDFC banks, okay, whether having deposit facility or not having deposit facility. Another option is that if you select all these features, suppose this way you can select all the points here, and if you minimize the attribute table, you can see the yellow dots, or these point features which are yellow in color are the HDFC banks that you have selected from the list. So you can also see your data, your selection, your filter options on your map also. Okay, it is not just associated with the attribute table only. This is another option. Okay, now there is another way of selecting or filtering the data set. Suppose the question are saying you have to search how many Axis Bank's branches are there in the data. So the question is similar to the question number 2, but another option you can do it. You have to right click the layer from the layer panel, and there is also an option of filter. You click it here and a query builder window will open. Here also you will see your fields here. So my question is, I have to identify the Axis banks. So I'll select, and this is the expression window. These are some of the symbols that are operators that you can use in the expression window. I'll say bank name. Okay. And if you don't remember all the bank names, here are the value options. You can either click sample, what sort of banks are there, or if you have to see all the bank list, you can click here all. So all the banks will be listed here. From this, you can directly take the Axis Bank, or you can double click it so that it will automatically shift to the expression window. Okay, Axis Bank, and you click here. In the expression window, what you have to do, you have to click the bank name equals to and the Axis Bank. This should be your expression to identify only the Axis banks that are there in the data. Suppose you don't know whether your expression is valid or not. So there is also an option of testing your expression. You can click here test, and it will say the clause returned 2 rows. That means the expression is right, and it will result into 2 options. These are the Axis banks. See what is the difference here is, it has filtered all other files, all other point features that were there in the data set. It is just showing only those features that are that fulfills the expression. So there are 2 ways of filtering. If you have to just see it from the attribute table, or if you want to remove other options. Okay, so I'll remove the filter here. You can open the query builder window again, and you can click it clear. You can click OK, and all your points will be visible again. Similarly, another example that I have quoted here is, how many number of banks are not having deposit facility? That means the deposit facility will be equal to 1, equal to 0. I'll go to query builder again, filter. You click here deposit facility, and all pay, when you go to all, it shows 2 options, 0 and 1. You can use 2 kind of expressions here. Either you say deposit facility equals to 0, or there is an option of exclamation equal to. This is just opposite of equal to, that is not equal to 1. This is also right. So you can test your expression. It results into 19 rows. And when you click it OK, you'll see only those banks are shown here on the map which are not having a deposit facility. You can also check the attribute table of these results from here. See, all the deposit facilities are showing 0 value. So these are the filter options that are there in the Quantum GIS. I'll just remove this filter here. Okay. All these questions are, and with expressions, they are being shown in the slides. I'll be providing the slides after this lecture so that for tomorrow's hands-on session, you can practice the data, and through these slides, it will be useful. All these 4 queries were there. I'll use another data which will be helpful to understand more filter options here. So we'll go with the Jaipur data again. Okay, and in the attribute table, what we have to do, the question is, if you have to identify any record, you can use it. You can use the field filter option. Suppose I said that you have thousands of entries in your attribute data. What if you have to select one record, or you have to suppose identify information related to one single record? So here the task is, suppose we have to identify the Tehsil Girwa and its associated population statistics. So from all the Tehsil names, what will I do? I'll go to field filter and I'll select this Tehsil name and I'll type here Girwa. Okay, you just hit enter. It will showcase only the features or the data that is associated with Girwa Tehsil. You can easily see any record which is there with the Girwa Tehsil. Similarly, what if you have to search for a particular number? See the literacy rate, we have to identify 51.14. Which Tehsil has this literacy rate? You go to field filter, you select your literacy field and you just type the number here. You click enter. So it is the Gogunda Tehsil of Udaipur district that is having literacy rate of 51.14%. Similarly, if you have to identify another number, another value, sex ratio you have to identify. So you go to field filter, select your associated field, enter the value and hit enter. So you can see here, it is the Jhadol Tehsil which is having sex ratio of 977. So in this way, you can also identify records that are there. The third part is using query in Quantum GIS. Now, the query options are a bit advanced. So far, we have seen the filter options and we have worked with the attribute data. Query is kind of using expression. Okay, so some of the expressions I have used in filter also, but query will involve some kind of advanced filter options. Okay, so we will take this one by one. My first query is, from the Indore ATM data, the question is, how many SBI banks are having deposit facility in Indore? So now here two filters that I have to do. So first of all, I have to filter SBI banks from all the list of banks, and from those SBI banks, only those banks I need which are having deposit facility. Okay, so it is a bit complex. Let's see how we're going to perform this. You open your Indore ATM data here. Okay, you open the attribute table, and in this filter option, there is a second last option. It says advanced filter expression. Okay, you have to click this. It is all, again, you are familiar with the window. It is the expression window, and these are all the functions that we will use in building the expression. Now, the building the expression is the task that we have to perform, and it should be very logical. Otherwise, software will give you the results or the output, but you have to also test for it whether it has resulted this exactly what we wanted. So expression needs to be checked again and again. I'll again go to the question. You have to say, you have to filter how many SBI banks are there having deposit facility. So here you go to fields first. What field you have to select? First of all, bank name. Bank name, if you click here, all you need, you will see all the list of banks. So bank name equal to State Bank of India and having deposit facility. So you will now use the operator function, which is AND. Double click it here and again you go to fields, select deposit facility. Deposit facility, all uniques, these are 0 and 1. Deposit facility equals to 1. All right. So this is our expression. Bank name equals to State Bank of India and deposit facility equals to 1. So now this query will work on your data. And you can see here preview says 0. That means your expression is correct. If it is invalid or if you have missed some kind of signs or commas or something, it will say expression is invalid. Okay, you hit OK. So now you can see it has filtered my query this way. 5 banks of state banks of India are there which are having deposit facility. And if you select these banks from here, from the attribute table, you can also see it on the map also. These are the banks. Okay. So this was one advanced filter query. Let's explore another query. See, find out either Canara or HDFC banks having deposit facility. Now the question is a bit more complex than the previous one. What you will do, let's do it from the query builder option. You go to filter, okay, and here you select the bank name equals to Canara and deposit facility equals to 1. You use a bracket sign here, okay. So the first portion of your expression will be Canara having deposit facility. Now it says either Canara or HDFC. So we'll use or, again use the brackets, bank name equals to HDFC and deposit facility equals to 1. Okay, let's just test this expression. It is valid. Let's say click OK here. Okay, and you can see 4 points are remaining. You just check the attribute table here. All the HDFC and Canara banks are listed which are having deposit facility. So this is an advanced query. How beautifully you can use the logic and you can extract as much as information that you want. I have given here the query expressions here. So in case you find it difficult to build your expression, query making is basically very logical thing. Okay, so by practice you can easily do it. Similarly, we'll say, or I'll just skip this section, but I'll just demonstrate 1 or 2 options here. You can use the Jaipur data. Okay, and from the filter query, you can answer all these 4 questions. The first question is you have to identify literacy rate less than 60. Now see here I'm using some mathematical functions. So how you will build your query here? First query is you go to advanced filter option. Okay, select your literacy field, which is, now use the less than sign here, which is less than 60. Okay, let's check your expression here. You click here, okay, and these are the tehsils which are having literacy rate less than 60. You can see it on the map also. Similarly, tehsils having sex ratio more than 960. And यहाँ पर देखिए, the third query says sex ratio above 960 and literacy rate less than equal to 30. So you just have to change the expression. You should know what symbols you have to use, what operators you have to use, and you can easily answer these questions. I have given all the query options here, so you can practice it from here. And the final output will be like this. All right. Now we'll come to the last segment of today's lecture. It is related with the spatial data query. We have seen some of the operations, some of the functions of that can be applied on attribute data, and now we will see what spatial data query options are there in the GI. And believe me, this is going to be very interesting for now. What spatial data is? Spatial data is the geometry that is associated with your spatial feature. Suppose this is a spatial feature in front of you, or I'll just open my spatial data files. I'll open all the shape files that are there in this. Okay, and I'll arrange polygon layers below and point layers above. Okay, so this is a data. We'll use it one by one. So what spatial data I was saying? Spatial data is that the geometry that is associated with this spatial feature. You are seeing a beautiful map here, but it is just not a sketch. It is having all the geometry information, all these points that are being there, that is making this whole polygon. It has a geometry associated with it, which is in the background. Okay, you cannot see the data here right now, but it is there. It is saved in the dbf file or projection file that you have seen in the various shapefile associated shapefiles. Now spatial query selects the geographical feature based on their location and the spatial relationships that they have. What spatial relationships could be there? Whether they are adjacent, features are intersecting. Suppose two roads are there and two roads are intersecting. So, or you can say a river is there and there is a road, so river is flowing below the road. These kind of under the road. So these kind of relationships are spatial in nature. For that, you need to have spatial data associated with your feature. What sort of spatial data or selection of spatial data can be done through GIS? So there are three options to select the data. First is you can easily select your feature using a cursor. What we'll do, we'll open a data here, and you can see this file, this symbol here, select feature. So you hover your cursor to any feature, or you can click here and it will say it is selected this way. Okay. Another thing is, if you want to see the information of this object simultaneously, what you will do, you will select this option. This icon here, you can see it is there and cursor option is there. So you click here, and this red one, this feature is selected here, and it is showing all the attributes that are there in the attribute table. So the name is Udaipur. Similarly, this is another district, Nagaur. In this way, you can select your spatial data. Another way of selecting data is, if you open this option, you will say select feature by polygon. Okay, you can draw a polygon here, and it will select all those features that are there that were there in the polygon. Similarly, you can select features by freehand also. What will you do? You select the freehand option here. You start cursor, your mouse here, and you just hover your cursor on the features that you want to select. This way you can select your features also. Another way is by select feature by radius. So what you'll do, you'll click this option and you have to just single click it, and you can use your mouse to increase or decrease the radius, and this way you can select any features using radius or a circle. So this was spatial selection using this feature. Another way of selecting features is by graphic that I have shown, and finally it is feature selection by spatial relationship. Now I have designed some of the questions here. We'll just see them one by one and we'll try to identify how we're going to perform this in the GIS software. First is, find out the road segments in Rajasthan where road cross over the river. So you see here the data is, this is a Rajasthan map. I'll just change some symbology so that you can easily see the features below it. There is a river layer. I'll give it a symbology. And you can also enhance the thickness of the layer. These are the rivers, right? Then we have a road layer also. Road layer, I'll give it a symbology of red color. Transport lines are shown as red in geography and cartography. So I'll use the red color here, and you can apply it and okay. So you see the road network is there and the rivers are there in blue color, and there is a state boundary. But these layers are not associated with each other, although they have the locational information separately stored in all the layers. Now what the question is, we have to check which road are crossing over the river. Suppose you are from engineering background and you have to select sites for bridge construction. So first you have to identify where a bridge is needed, right? So from all this data set, or you can see the data is so complex that you cannot easily or manually do this by checking all the layers one by one. We need that software easily give us this output. So there is an option. You click here, this symbol, okay? You click here and you go to, sorry, this one, location symbol is there. You click here. It says select by location, all right? Select by location and see the inputs that we need here. It says select features from, you have to select the feature from road that cross. These are the geometric options or spatial relations that are possible in GIS data, whether it is overlapping or it is within or equal, disjoint, contain, intersect. These are the options. So road, cross, what? River. All right. So this is I have already given expression. This is a kind of spatial expression that we have given here. And you click here, run. This query has been done. Now you see here, some parts are highlighted in the color, in yellow color. I'll give it a dark background so that you can see the yellow lines. So these are the selections. These are the roads that are crossing the rivers. See, this is a river, this is a road coming here. Similarly, even for this small segment, this is a road and this is a river. So it has selected the roads that are crossing the rivers. Isn't it interesting? Let's explore another thing. Find out the tehsils that are having schools. Suppose you have a school data, all right? We have shown it here. And we also have a Rajasthan tehsil map. And we have to identify on the map how many tehsils are having or have schools. Okay. So again, you go to select by location. So schools that, or you can see tehsils that contain schools. The expression will be tehsils that contain schools. You run this expression. See, if you disable the school layer, you can see all those tehsils that are highlighted with yellow color. These are the tehsils that are having schools. So on the map, you can identify those tehsils also which are not having schools from this given data. All right. So this is another way of selecting features. Next query is find out the tourist places that are within Jaipur district. Now see, it is a bit complex query. What we have the tourist place information. Okay, these are the tourist places across the Rajasthan. But the second part of the query asks that we have to just identify tourist places that are in the Jaipur district. So for that, either you need a Jaipur district map. But what if you have the Rajasthan district map? Firstly, what you will do, you will filter Jaipur from the Rajasthan map, and from that you will identify tourist places. So there are two parts to this expression. First, we will use the query builder option on the Rajasthan district layer. So you right click it, filter name. You see the samples here. So name equals to what? We have to select for Jaipur. You test this equation, it is 1, which is Jaipur itself. Now you see all other districts are hidden. Okay, it is not shown on the map. And now we have to just identify tourist places that are in the Jaipur district. So when you select the feature by location and you give here the query has to be tourist places are within Rajasthan district. But you don't have to worry now because you have already put a filter on this layer. So it will just showcase the selected features that are in the layer right now. So it will be Jaipur only. Tourist places are within Jaipur district. You run this equation and you see these tourist places are highlighted. Only those tourist places are highlighted that are there in the Jaipur district. Okay. So this kind of advanced filtering options are also there. Let's explore another query. Find out the river channels that are not flowing through Udaipur district. Now, you'll be able to filter the Udaipur district from the whole Rajasthan district map. You have the river channel layer. But the question is, these rivers are not flowing. So we will use a disjoint option. And our query will follow river disjoint district. Okay. So I'll just remove first initial filter here so that I can see the whole map. I will use the river layer, and in the district I'll select the Udaipur district first. So the expression will be name equals to Udaipur. You click here OK. Udaipur has been selected, and these are the rivers. So I have to identify which rivers are not flowing through this. You go to select by location. You say rivers disjoint the Udaipur, Rajasthan district. So you click here run, and you see on the map all the rivers are highlighted. The yellow color is the selection color. Okay, so these are selected. These are the rivers which are not flowing through Udaipur. You can see the rivers which were flowing through Jaipur are not being highlighted or not being selected. So these are different query options there, right? And also you can see how many number of features are there. It gives you total number of 83. You again select it here from river disjoint Rajasthan district. Okay. So you see here 83 features. Okay, on the bottom taskbar you can see 83 features are selected in the river layer which are disjoint or which are not flowing through Udaipur. So you can count on the features also. Okay, this is one way. So the last query we have is find out the schools in Rajasthan that could be affected by flood. Okay, suppose there is a situation of flood. So you have what data you will need. You need a Rajasthan school map or school layer of Rajasthan, all the schools as point files, and You need a river layer also, because floods will be there around the rivers or through the course of a river channel. So suppose we say that in case of flood, river will get extended up to 3 kilometers. All right. Suppose all the rivers are having flood. We have created a hypothetical situation. So first we will create a buffer. All right. Buffer to the river layer only. So you go to vector here, and in this geoprocessing tools option, you go to buffer. There are various options that can be performed on the vector layer. I'm just using this buffer option here. So you go to vector, geoprocessing tools, and buffer. Your input layer is rivers. Suppose I say the flood zone is about 3 kilometers from the river bank. So you select distance 3, and you have to select the unit also 3 kilometers. All right. And keep these other parameters as default. You run this application and see a buffered layer, a new buffered layer is created. I'll just put a river layer above it, and you can see these are the rivers, and this pink zone is the buffer zone of these rivers. In case of any flood situation, this will be the area which will be affected by the flood. Now another question, another problem, the part of the problem was we have to identify the schools. All right. So let's say we have this school layer, and we will use the spatial selection option again, select by location. Now the select feature will be select the schools which are within the buffered zone. Okay. So I have used the buffered layer here. Schools are within buffer. Let's run this equation. 20 features selected on school layer. And you can see on map also the points, the school point which will be affected in case of flood. So in this way, especially for planners, it is a very important aspects of spatial selection. So you just need all the sorts of data layers in it, and you can add expressions, you can make logics to the problems, and easily identify the spatial solutions to this. So this was all from my side. All this all these demonstration will be doing it in tomorrow's hands-on session. I'll be sharing the data map. So
Okay, madam. Ji.
if anyone is having any query or want any explanation, I'm there. Over to you, ma'am.
Okay. Any query from participants?
I'm sorry, ma'am, but I'm not able to hear you.
Oh. Am I audible?
Okay,
Sir, am I audible? Urmi ma'am? Okay.
Yes, ma'am.
Okay. Any query from participants? It was a wonderful presentation, madam. Very insightful and great presentation. You actually demonstrated, I think, so many query options for attribute as well as special data. And I think the examples were so cautiously chosen that everyone will be now, they must be feeling comfortable with this software. And I hope they will be able to generate or frame the query statement and as well as run the query also. So wonderful presentation, ma'am. Thank you so much.
Thanks a lot, ma'am.
You'll be sharing, ma'am, some data for next day session.
I think there is one question from Sushma ji. How to find a range of values? Sushma ji, can you please explain in which segment of demonstration you were asking this question? Hello? I think that got answered. Okay, okay. Okay, ma'am. So, any other question from the participants? Advanced filter option will be used. Okay. I just want to add here that lot many functions and filter operations are there in the Quantum GIS, and you can also I've also shared references here. Okay, there is a link here. This one Quantum Docs. I'll just share my screen. Right. So there is a link here in the last. It is a user manual, and all those expressions, what is the use of them, these operators and functions are given here. So you can check this link also. Okay. Anything else, ma'am?
Okay, yeah, that's fine. Ma'am, can I request you to share the presentation also so that it will be helpful for the participants?
Sure, ma'am. I'll share the presentation and data as well.
Yeah, thank you so much.
Okay. Thank you, ma'am. Thank you so much.
Okay. So can we end the meeting today? Meeting of the today? So thank you very much, and tomorrow we'll again